Okay, so let me just put the timer here. So we're going to talk about what we've been doing over the past almost 3.5 years on leaks at the ICIJ. It's very important to understand what we do, to understand who we are and what our needs are, right? So the International Consortium of Investigative Journalists, we are a part of the Center for Public Integrity, headquartered in Washington, D.C. We are a media organization that produces cross-border investigative stories, but at the same time, and most importantly, we're a network of journalists, of investigative journalists all over the globe, that basically we're a network of trust and of trusted journalists that work together on very sensitive topics. ICIJ is a very small place. People think we're very big, we have a lot of money. We don't. We have 11 people working as full-time. And as I was saying earlier, 50% of the team is now the data and research unit. We have 3 programmers and 3 journalists working together, developing not only data analysis and, for the projects, but also tools to help journalists deal with the content that we produce and the leaks that we've been working on. Just to give you some idea of the cases we've been working on, the stories we've produced that are connected to the software that Matthew is going to mention in a second. Our first big leak project was in 2013. It was called Secrecy for Sale or Offshore Leaks. Later had an iteration called China Leaks, which basically was based on a hard drive of 260 gigabytes that had many different types of documents, mainly 2.5 million files, 2 million emails, and some structured information about 100,000 offshore companies. We later dealt with another leak that was very small in comparisons in terms of size. We were dealing with more than 500 secret tracks agreements that were just PDFs. I mean, just. And later, we just recently published in February this year, an investigation called Swiss Leaks, which was we basically got access to the client database of part of the client database of HSBC, one of the biggest banks in the world, and we had information on who were their clients in Switzerland. And that information amounted for like $100 billion for one specific year. Basically what we do is we work in collaboration with big media organizations from the beginning, so they're part of our reporting team. In Swiss Leaks, we gather 170 reporters in more than 50 countries. We're currently working on a project that is even gathering more reporters than that. And I think, to me, the key is that we work together. They're not publishing organizations for us. They are reporting partners, and we report together from the beginning. Our average project takes between 6 to 8 months, sometimes even more. And we have several tools that we've developed based on open source software, but we want to mainly explain what we've done with the documents. So Matthew is going to talk to you about that.
Okay, this is where the flashy photos end and where the boring slides begin. So when our leaks come in, the typical way we get things is on a disk, like a removable drive. And what's different about the leak that we're working on now is the sheer variety of the files. We're talking about emails, spreadsheets, Word documents, PDFs, TIFFs, all kinds of things. And what we want to do with this, it's the same process that we've used in other leaks, which is taking the raw files, getting the raw text, also taking the metadata, for example, from emails, the email addresses, subject line, from PDFs, the author, let's say, putting them in a database, and then making them accessible on a search and discovery platform that journalists will actually use. The process for actually getting the text and metadata out of the files is this basic recursive process. So you start with the file, detect the type of the file, figure out whether we know how to extract from this type of file, whether it's a Word document, a PDF, or an email. If we don't know, then the file name and type is logged, and later we go into iterative development and see whether we can handle this new file type. If we can handle it, then we start the extraction process. We use a library called Apache Tika, which bundles a bunch of other libraries, including POI, for extraction from documents, PDF box for extraction from PDFs. If the document is an image, say a TIFF, or if it's a PDF which contains images, or an email which contains image attachments, then that goes to Tesseract for OCRing. This is endlessly recursive. If an email contains an attachment that contains PDFs, that contain images, those are also OCR. The problem is that we have so many files, a lot of them are TIFFs. It takes an average of about 10 seconds to get the text and metadata out of every single file. With 3 million, it's going to take us a year to get all this text and metadata into a database running on a single machine, running a single instance. So our solution in this case, with 3 million files, and when it started about 1.5 terabytes of data, was to build a queue of all the files that needed to be extracted and indexed, and setting up an array of, in this case, 35 Amazon instance G2X large type Amazon instances, which I think cost about 60 cents an hour to run, so it's extremely expensive. And we use this array to do most of our extraction, actually all our extraction and OCRing. All the text and metadata that comes out of these machines goes into a single Solar instance. Remember that each of these machines they're 8 core machines. So each one of them is running at least 8 instances of Tesseract at any given moment. So it's 35 multiplied by 8. And all this data is going into a single Solar machine. We found Solar to be extremely reliable. It can handle this much data flowing at it, 8 times 35 simultaneous connections to it. And that's a single machine. I think it has 4 gigs of RAM, and it manages it perfectly. So with this, we managed to reduce our extraction and indexing time from a year to 11 days when you count the days that we weren't working on when we weren't working on debugging. Our process is a bit more streamlined now after all the bug fixing. So if we were to go back and do it again, it would actually take 11 days. As a front end for Solar, what actually allows the journalists to search through the data, navigate the files, view the extracted text, download the actual files, and so on, is a project called Blacklight, which it's Ruby on Rails. It was originally developed for libraries, but it plugs straight into Solar, and we found it to work extremely well for what we want to do. It's open source, so we've done very heavy development on it to add a lot of features that the journalists who are using it need. We haven't released these features publicly yet, but when our version of Blacklight gets close enough to get stable enough, we will probably publish it. We will probably open source our changes. What's good about using Solar is that we can use Lucene queries to do a lot of advanced stuff. One example here is that we're doing proximity matching. So if you can see in the query box, we've put Joaquin Loera, which is the real name of El Chapo Guzman, the cartel boss in Mexico, and we get these kinds of results where, in Spanish this is very important, but sometimes they put one surname, sometimes 2, sometimes there's a middle name, so we get hits even when there's a middle name used. This is just one example of the kinds of queries journalists can do, which are extremely useful. In French, for example, sometimes the surname goes first and the name goes after. With proximity matching, that isn't a problem. We currently have about 200 people who are using this system, and it works fairly well, I think. It's stable, though, you'd say.
No, this is for a project. The current project we have.
Okay.
So 220 journalists having access to this project.
But
So
not
it's
exclusively ICIJ.
not its ICIJ members,
No.
it's members of this project, which are some ICIJ members, some journalists, some are not trained as investigative journalists, are just journalists that have been put into this very specific project.
In this case, in the results, we're looking at an email. It's a message file exported from Outlook. This is a sample of the text from the document. With Solar, you get automatic highlighting. And so on the results page, the journalists are seeing it's like Google, you get the text with the highlighted bits. And this is the metadata that was extracted from the file by our extraction tool. In this case, the subject of the email, the person who sent it, and the date it was sent. Why did we go to that?
Yeah, because it goes with animation. Go next.
I see.
Yeah. For us, so what Matthew showed is the document platform we have to search, but for us, searching the documents is one step. What is very important is that the journalists share what they found. So even though this is a less developed tool for us, having a virtual newsroom for journalists to share their findings and comment and so on is very important. And it also feeds back to what people are searching, how people are using it. We post even like webinars, trainings, like documents here on how to use the platform, and also on how to investigate together, because as I was saying before, for us it's about content, it's about publishing the story, making the big splash. So we've worked on, we got an open source social networking platform called Octwell, and basically it's basically made for like social networking, like finding a boyfriend and girlfriend, you know. There's like in the form that you have to fill in to create a user, there's that possibility of, are you looking for male or female? You can later tweak it. We have disabled it. But it's basically what allows us to have, it's a bit like Facebook. It has like a news feed where like the latest things are. It allows us to have forum, like so threaded communications. It allows us to share links, to share files, and basically to be up to date on what's happening in this global virtual newsroom.
It's where a lot of discussions on feature development happen, because almost all our feedback from journalists comes through these platforms, and that's where we figure out what people actually want, what features people actually want.
Or even learn how people can use our platform better. We've learned like a lot of things that we didn't know. And just to give you an idea, we also use other tools. For us, it's about what is the best tool out there that requires less development and gives us a solution as fast as possible. So we've been using Linkurious for graph analysis. So this is an example of the data for Swiss leaks for the HSBC data. This is Emilio Botín, which was Spain's main banker and owner of Santander Bank, which you may know. He had a bank account in HSBC Switzerland. And this is the network, right? So what Linkurious allowed us to put the data into Neo4j, plug it in here, and very easily have a graph database up and running for journalists that are not tech savvy to just expand nodes, which is something that
Where does links come from? Are those human created?
Okay, this is what I was going to say. So our data is divided into two parts. The majority of it is unstructured data, all document, PDFs, message, emails, and so on. We also have a small part which is structured data, which came from scraping. It's data which we generated ourselves. It's a product of which we generated ourselves. We scraped web pages and obtained the structured data. That goes into Linkurious. Okay. But the bulk of our data is unstructured, and that's available on Blacklight.
Yeah, because we've had a problem that within the leaks we've got, we haven't got like V database. Even in HSBC, in this case, we got Excel files which were outputs of the client database of HSBC. So we had to reconstruct the database and then create Linkurious.
Our structured data is always reverse engineered, and then it goes into here.
But if you have a database, of course it's easy, no? What is you want to say? Because we're running out of time.
This is a little bit about, just to give a summary of our stack, to explain what technology we're using. The tool that we use to do extraction is something that we've developed ourselves. That Tika, I don't know if anyone has used Tika before. It comes with a command line tool, but it's very basic. So we started a project ourselves, which we've open sourced. It's called ICIJ Extract, and it's open on GitHub. And what it allows you to do is what you're doing. It can connect to a Redis queue of files, and it will start processing all those files and spit them out into Solr. It bundles Tika, the Redis libraries, SolarJ, which it uses to connect to Solr, and it comes with millions of options for every use case we've had so far. So it's much more advanced than the Tika command line app. It also bundles some other libraries which we've found, because we're dealing with a lot of exotic file types. We've bundled in a lot of other libraries that help Tika deal with these files. For structured data extraction, we use Python. The main database we're using is Apache Solr. We use Redis to control the queue. And Neo4j is what Linkorius runs on. The front end application is Blacklight. That's a Ruby on Rails application. It's also open source. The only closed source thing that we're using is Linkorius. That's written in JavaScript. So if you do actually use Linkorius, then you can read the source. It's there in the application, but the company doesn't actually publish it, and the license doesn't allow you to modify it. That's the only closed source thing we're using. Okay, now Mari is going to talk about the next steps for us, the things that we're going to be working on earlier next year, which are entity extraction, and a big problem for the ICIJ and a lot of organizations, which is that once these projects are over, the data just sits around in silos and doesn't do anything. We depend on journalists to go into these silos and do manual searches based on hunches, which is a very, very bad way of doing things. And I think that that's the next step for us as programmer journalists. We need to figure out ways of making these different silos of data talk to each other.
Right, so basically, because big problem for us, we have a Blacklight platform for offshore leaks, not for offshore leaks, but similar platform in DT search for offshore leaks. We have a platform from LuxLeaks, we have a platform for SysLeaks, and then leak. So right now, and as you can see, they're all about offshore, right? So there should be a crossover connection between all of these leaks. So that's what Matt is saying. So we're thinking our next steps is how to put them all together, because most of them are in Solr and in Blacklight, right? But on top of that, which is a challenge, our current challenge is trying to, on top of making our leaks work or our databases work and talk to each other, is to create a way where we can actually drag from the knowledge and documents and data that our members have. I don't know if you remember at the beginning, I said that we're a network of around almost 200 journalists in the world. So they, of course, investigative journalists, and they have a lot of documents in their computer and a lot of data. We did a survey, and when we asked them about the type of data that they had, the majority, like more than 80% of the things they had were Word documents and PDFs. So very few had Excel sheets, you know. Of course, if you're asking to US journalists, they have a lot of databases and so on, but the rest of the world not. So we're dealing with things like, okay, we have offshore leaks, we have bank account information, and maybe we can gather information from UK contractors, right? And that's within ICIJ for the projects we have. And sometimes we do, okay, let's do a match to see if there's a match with the sanctions data of the US. So it's a one-way data check for a very specific project. But what we want is that, you know, maybe our Indian reporter has Indian politicians, and our, I don't know, Argentinian reporter has a list of Argentinian fraudsters. So we're trying to devise a platform that basically allows us to do crossover matching automatically from all of those data sets. Problem we have, as Jonathan was saying, is access, access rights. Journalists don't want to share everything. So the solution we've devised is we are working with the Polytechnic University of Computer Engineering University in Madrid to develop a tool that would allow the journalists to do basic, simple entity extraction from their documents, and then, create an index. That was actually Paul's nice contribution of kind of like, okay, journalists don't want to share all the documents. We're interested in the people, the companies, and the addresses. So let's share an index of the people we have information in, companies if we have information in, etc., so that matches fuzzy matches among itself, and you maybe get an alert if somebody has some things that sound similar to what you have in your computer, and then you know you have to ask that person. So Matthew uploads something about El Chapo Guzman, I have something about El Chapo Guzman in my computer, and ideally the computer tells me, hey, contact Matthew because you have documents that might be talking about the same people. This is a concept idea. What we have for now, and I'll go into your question in a second, is we are working on how can we create a basic, simple tool that can allow that entity, that index to be created. So that's what we're working on with the university within the next 3 to 6 months, starting October.
Okay, so I'm going to just try and keep this really short. The long story short is we're doing pretty much all the same things, but we've been building this investigative dashboard platform for a while. This is kind of the new layout of it. We have it in staging at the moment. It's about to be launched, so there's an older version on the main site. But it's got a bunch of features. In basics, we've got about 2,300 registered users, but in practice, there's much less activity, about 100 active users, give or take. We've got about 550,000 documents indexed, but the system was originally based around research tickets, and there's about 2,500 of them, so people can log in, make research requests, ask about companies, ask about people, or whatever they want, and get information back. We've also been starting to work on an entity relationship system, which is about 20 million entities, but we've got a huge, huge backlog of stuff. So it's based on Python and Django. We are slowly moving to a RESTful API, so just to try and break things out into smaller services that are kind of loosely coupled, and then Postgres, Elasticsearch, trying to move to Angular for front-end stuff, and so on. Some of the modules are HAPL'd. We kind of want to be generally open source on things, and there's just some kind of dealing with older code and making things clean and nice. So the challenge really that we're trying to deal with is we're sitting on multiple terabytes of data that needs to be processed. And these are broadly categorized into piles of unstructured files in various formats, everything from PDFs to Excel files to Word documents to whatever. And then we've also got lots and lots of structured data, so the CSV files typically, but also other types. And all this needs to be processed, indexed, and understood. And to complicate matters, we routinely work in about 17 different languages using 4 different writing systems, which makes anything like entity extraction or OCR or anything like that incredibly complicated. So generally, we're trying to solve this big problem of our journalists in the field are trying to get work done, and we just develop whatever is needed to suit their purposes. But rather than doing this kind of piecemeal, single-purpose task or tool, we're trying to make things more broad and more generic so that they can be used for anything. And of course, we've got over 30 organizations in our network, which, and not all of them necessarily always want to share with each other, so we've got the privileges and permission stuff that ICIJ was dealing with. And to boot, we are working in a pretty difficult environment where our servers are constantly under attack, and people really don't want us to manage to do our work. So we've got to be dealing with all this different stuff. So ID has, just to run over a few of the features, we've got a set of business registries, which is basically a database of databases. Very good kind of simple starting point for doing investigations. We've got the information requests, so this is one of the kind of oldest and most stable parts of the system, where people are making research requests that are then responded to by our researchers. And owing to the fact that we've got lots and lots of journalists with huge data sets on their computers, we wanted to build this kind of like a place where people could store their files, a bit like a Dropbox kind of thing, except that it would do the indexing and processing automatically and allow people to access their files. But with the nice feature that when you've added some files, you can say, okay, I want these to be public now, or I want to share these with other colleagues within a network. So this is one of the newer features in the system. And this is entirely responding to just the insanity of having, terabytes of files lying around on different laptops and hard drives and all sorts of things, around lots of different countries. So just trying to make things simpler and easier to manage and easier to understand. We've got a document search front end, which is basically searching on this 550,000 document data set, which is already indexed. But in addition, anything that's been marked as public or anything that you put in your file store also comes up in this search, or that at least is the plan. And then, because we had this nice little Investigathon kind of event a couple of months ago, we made, just as a response to needs that came up during that little media search thing, where you can select the location, put in a search term, and choose dates and times, and get results that may or may not be relevant to your investigation. The downside of this is, we've got a couple of endpoints for that: Instagram, Contact, and YouTube. Turns out that no matter what search term you put in, you will almost always get selfie pictures, which makes it less useful. But still, this is this was actually based on an idea that came up during an actual investigation into Broken missile launchers in Ukraine. So the roadmap, this is all under heavy development. We are releasing the version 2. It's in staging at the moment, as I said. Basically, it's taking a long time to load database stuff in. We support the research tickets, file management, database lookup, and this kind of meta search engine. And we've got 2 development tracks going on, both trying to solve particular needs. One is that we've just got all this entity data lying around the files. Want to extract all that out and be able to just make sense of it all, figure out the connections between people and companies, and court records and tenders and all these other types of data. And for that, we want to use natural language processing methods. We want to use the natural file formats that exist in the cases like when we get CSV files or such. And making that all linked together and be fast at the same time, being able to do pattern searches on the database, is kind of important, because one of the things we frequently see is patterns of corporate structures, for instance, that are clear indications of wrongdoing. And if we can find them based on a pattern search, then all sorts of interesting investigations can kind of fall out. The other thing that we're starting to try to deal with is the fact that the editorial process at the moment, which is kind of the back end of the journalism, once all the research has been done, is currently an absolute mess. So the typical way this happens is somebody sits down, writes a bunch of stuff in Word, emails it to his editor, and then there's backs and forths, and eventually somebody is going to end up editing the wrong file, because emails are not the right thing to manage collaborative document editing. You have, of course, things like Google Docs or whatever, but they don't have the kind of good editing markup features. And on top of that, of course, you've got all sorts of other assets that are related to a story, whether those are files which are currently in our system, videos, whatever, artwork, and also translations of the story into whatever languages and all of that stuff. So we're trying to kind of, trying to not reinvent the wheel if we can avoid it, but still address the fact that the kind of editorial pipeline is an absolute mess in most cases. So all this is being developed internally within OCCRP, which I won't bother introducing as such. We've got a website. Essentially, the sustainability of this project is based on OCCRP's continuing need for this kind of technology. And while there is a need, there will probably be some kind of technology department in OCCRP doing this work. But of course, the more we can open source of it, the better chances are for feedback from other users. Just as kind of little structural diagram, this is kind of how things are related at the moment. So most of the things we need either do exist in some form, but again, heavy development, and it's all pretty young and on the way. So yeah, that's basically me.
I am pinch hitting for DocumentCloud. DocumentCloud had a board meeting this weekend, so literally everybody on the team was unavailable. So I sent them a bunch of questions, and they trusted me enough to represent them. So DocumentCloud. DocumentCloud is perhaps the oldest and largest data sharing or document sharing platform for journalists. It's also the system into which the most money has been poured. So we're now looking at $2.5 million in grants. So they haven't spent all of it yet, but they're working on it, and they're also working towards a commercial model. Just again, as a reality check on what it costs to build and support this type of software. So getting user count for DocumentCloud is a little bit complicated. They have 1,400 organizations. Each of those can create an arbitrary number of accounts. So they've got this two-tiered organization and user model. That's part of how they do access control as well. You can share with particular people, or you can share within your organization. And they've got about 2.5 million documents. So they're the largest system by user base. In terms of active users, no question. In terms of number of stories done with DocumentCloud, no question. It beats all of these other systems by probably 2 orders of magnitude. It is not the largest system in terms of the amount of data being managed, actually. It's a very modest amount. That's because DocumentCloud is mostly used, and in fact, I would say, in fact, optimized for small sets of documents. So I have that one page, or I've got these 5 files. But as we shall see, that's part of why it's been successful. They built out good import first. Version 1 of DocumentCloud had all of this stuff, except maybe multiple languages, I think, came later. But you could add a document in any format, and it would automatically OCR it and give you a viewer. And I find it kind of shocking that there are a number of document analysis tools in journalism that don't do this, that make it hard to import things. I think all of the projects here now are at or near the point where you can drop a file full of folders onto them, and it'll just go. DocumentCloud is still the only one of these projects with an embeddable viewer. I think, again, this is a key to their success because it addresses what journalists actually want to do with documents, especially journalists who are not investigative journalists. They very often just want to show what they found. And so here's a sort of moderate level complexity use of it. So this is the actual viewer. You can see public annotations, and then it's got an API so you can build things around the viewer. So here they're showing different categories of documents and annotations. And a lot of people have used this. Here's the Washington Post talking about some of the Snowden documents. Their embeddable support is quite good. It's getting better all the time. It's one of the things that's most requested. So they recently did OEmbed engineering to support it. So that's just a smoother way to embed a document view into lots of different types of systems, into WordPress, into whatever crazy CMS you have. And they're always getting requests for new features in their viewer. In fact, it's one of the things they're doing is re-engineering this. DocumentCloud, as an analysis tool, I think is somewhat weaker. We'll get to that. They're very good for collaborative access. You can see the basic access levels you have is you have public, then you have completely private, and then you have private except for the people that I've added. And then you've got all of these tools, many of which are collaborative, so you can add both public and private notes. You can move pages around, you can redact things by drawing little bars over them, and it will securely remove that from the files. There's all kinds of really boring, straightforward, phenomenally useful stuff that you can do with DocumentCloud. Analysis tools. They do support entity extraction, but in a somewhat limited way. It's done through OpenCloud. I don't know how many have used it. It has certain strengths and weaknesses. These little sliders, it shows you where the entity is appearing in the document. So one of the problems with OpenCloud is there's a lot of noise. So it found, issued capital as an organization. Another problem with their analysis tools is that it shows you per document. There's no way to get a list of all of the entities in a set of documents. So DocumentCloud has really been engineered around individual documents rather than sets of documents. And that shows up in a lot of their design choices. They also do timelines also through OpenCloud extraction. So it's...
It's still just those 4 languages, right?
No, it's got a bunch more now. I'm not sure what the exact count is, but they just announced a bunch more languages. You can search, of course. The backend is Solr, like everybody else, and they have advanced search queries. So like the proximity search that we saw in ICIJ, I think actually all of the platforms we're going to talk about support it because it's all done through Solr. So to get your own DocumentCloud, so the code is out there. You can run it on your own machine. It's getting easier. I don't think it's Dockerized yet. So that means you still need an engineer to mess around with your servers for days or weeks. The access model is kind of interesting, right? So they encourage people to make documents public. That's part of the concept, is a public document repository, which it succeeds at. There's millions of public documents. But to add documents or to use the system, you have to be a journalist. You have to write them and say, I would like an account. And they basically give out master accounts to organizations who then give out sub-accounts. They are beginning to experiment with giving out accounts to other people, and they're experimenting with asking other people to pay for accounts as well. This also makes it a little harder for freelancers, although it's certainly possible. There's lots of freelancers. And if you are an organization who has a freelancer, you can add them as a collaborator. They are part of IRE, the Investigative Reporters and Editors Association, or I think they're just called Investigative Reporters and Editors, which is itself a nonprofit. So it's very much this like community resource business model or concept, and they're entirely grant funded so far, but they are, the reason they got another $1 million from Knight was to move towards being customer funded. So I asked them about roadmap and sustainability. This is what they said to me. Mobile ready viewer. I think it's the only project which has got that far. And then a big redesign is coming as well. I think this list is as interesting for what it contains as what it does not contain. So again, they're the only ones even talking about mobile so far, but they're not talking about entities at all, really. That's not their bread and butter. And they haven't announced a sustainability plan, but I know that they've done a small number of deals with folks who want to have access to it who aren't journalism organizations.
I'm going to start off with a demo. So this is the problem. We have lots of documents. The solution at the bottom here, overview docs. Overview docs takes a lot of documents. Think of it like a folder full of PDFs. So you have a folder full of PDFs. What do you do with it? I mean, that's the ideal, right? That's the dream. Usually you'll have a folder of Word documents and spreadsheets and whatever. But let's just say you have a folder of all these things. You really want to find a story in there, and you don't know where to start. Well, you start with overview. So you just go to Upload Files, and then you find all your files, and you just pick a bunch of files. This is Jonathan's computer, so we'll just do it. We'll just upload it all. Anyway, you upload all the files, and then you give them a name. So last night, just to sort of test this out, this is a set of documents that I haven't looked at before. It's the Clinton emails. Backstory for non-Americans. Hillary Clinton is this pretty important person who wants to become president. Speeding it up, she kept all her emails on a private server while she was Secretary of State. That made a lot of people angry because they felt that this should not be on somebody else's server. It should be on government servers. So to clear up the whole mess, a lot of these emails are getting public, and people want to they say, wow, we have a lot of emails. What do we do with them? So I just went online and I Googled, find the emails, and I downloaded them all, and then I uploaded them into Overview. And here's what you get. So luckily the emails were all PDFs, made it really easy, but Overview handles a lot. And there it is, it's a list. The nice thing is you can flip through. So here's the first one. It works better with a faster internet connection, but even so, not that bad, right, to flip through all the emails. And then, the killer feature here is search. So if I search for Clinton, obviously it's going to find every single email. And then over here, because it's so important, it highlights. Now, this particular data set is frustrating because the highlighted word is somewhere near the top. Actually, I can't even find it there. Anyway, the word Clinton is in there somewhere, and it's highlighted. All right. Oh yeah, phrase not found. That is weird. It must be in the. It's matching on the title. Yeah. Okay. So let's take state. This will be it'll be in all of them, and this is what I was saying. Like it's up there, right? It's underneath the little search box. We do what we can with the tools we have. We want to make this better. Document mode. We also have text mode when you want to go really quickly because the text loads a lot more quickly than the whole PDF. So that's search. But then our killer feature comes with this little box over here. These are our plugins. So the story there is we have an API that you can use when you've uploaded your documents. You get a little key, and you can just quickly get a whole bunch of information out of the documents. So this word cloud, for instance, what we do is we just stream all the words out of the document. We have a little thing. It does the tokenizing for you. So you just get all the words. And this is only 8,000 documents, so that takes a couple of seconds to build this word cloud. And then we have this tree, which does topic modeling. I don't understand that much about it. A lot of people swear by it. A lot of people hate it. The cool one that we've been working on lately is called entities. So this is another one where we use our API. We find all the words, and then I created a data set of words that show up in Google Books. And so Google has a list of all the books in the world and all the text of all the books, and they've just, they published this data set of all the words in all the English books. And, if you take out the lowercase words, just the 50,000 most common lowercase words, normally what happens is you get a whole list of things, but this internet connection is a little bit flaky. No, it's sort of stalled. It's not supposed to take that long. So I'll just refresh. Then it'll come up here. We can show you some other time. We have the tree. We have multi-search, which is a pretty simple plugin that just lets you, keep your list of things. So if you really care about Cheryl, then you put Cheryl in there. And then if you care about Sullivan is another name that pops up in the entity finder. And then it can, you can say, well, let's set Sullivan as a filter. How many documents contain Cheryl and Sullivan? And it's 788. So we support these file formats. We want to support more. We support OCR. That's new. And right now it's really slow, but it works. And this is another important one on any deadline. And any question. This is what the plugins are about. You can throw new problems at it. It's covered the basics, and you get to cover the new problems. Okay, so users. We have 200 users using it every week. We've had a total. It's been around for 3 years. Mostly it was built by 2 developers over those 3 years. 32 million documents, 5,000 document sets. The core is in Scala. That, I don't know if it was the right choice or not, but with our tokenizing, it's worked out really well with getting these plugins to get the tokenization for free. Our plugins are all on Node.js just because that's something that we feel a lot more people can code. Next steps, we want things to happen faster. We want to support multi-user things. So we have a tagging feature. A lot of companies have multiple users going through their stuff. They want to tag them or add metadata with many users at the same time. We don't support that. Undo is kind of a running joke because we've always wanted it. We don't have it. And another big feature that we're just waiting for somebody to pay us for is timelines. That's going to be the next thing. Just put it all in a bar chart by time or something. Service costs $700, $800 a month. We could bring it down, but this is a good amount to let us develop more quickly. But our big expense is developers. We get our income from grants and from contracts, and the sort of sad thing is we have no sustainability plan. So we are always looking for ways to collaborate with people. And there you go. Oh, more questions?
What are the best stories that have come out of this and what features have they used?
Best stories. We do keep a list of some of the stories, just a few of them. And one of the ones that I found interesting is this analysis on the Atlantic of Louis C.K.'s emails. This reporter just wanted a way to browse through PDFs, basically. He just went through and read each one, but it's a little bit quicker than a file browser. So.
All right. So I would propose that we reconvene at 1:30.